Hello everyone. Uh, Myself Pragati Srivastava and my team Carlos and Rushta, we have created a checkers game using Minimax algorithm for the final project of artificial intelligence. So the basic rules for the game are that it is a two-player game and each player will have six pieces. Blue piece represented by B is for the computer and the red color piece represented by R is for the opponent, and the pieces can only move forward and they can move diagonally left or right if there is an empty spot, and the players can capture a piece only if the next diagonal is empty and if there is an piece of the opponent available there. In that case, both the computer and the opponent can capture the pieces of one another, and in this way they have to move forward to the opposite side of the board. The game will end when there are no pieces left for either player or when no valid moves are available for any of the player. And the player with the maximum number of pieces left at the end of the game will win the game. And if both the players have same number of pieces, then the player closer to the opposite side will win the game. So we have created a console application using C Sharp for implementing this game and the algorithm used in this game. So let us see a small demo of how the game works. So this is the main file to execute the board. Okay, so this is the initial board. Here, these are the computer's pieces and these are the pieces of the opponent. And so there are the various options like which piece we want to move and what are the various commands which we can use to move the each piece. So let's start the game and enter a command. So we have moved R1 to the left, and so here is a space now, and then after that the computer takes his move and moves his player to the right hand side. So these moves how the computer is taking is decided using the Minimax algorithm. How it works that we will see in some time. So let's see some other moves which this application can take. So let's enter a different move now. So see, we have moved a different player here, and then we will, and see if we moved R2 to the right hand side, and as we moved it here, there was a blank spot, and that's why because of this blank spot, B5 captured R2 and the computer's piece has moved to this place. Now let's capture one of the computer's piece, and so see here, we have captured the piece B4 and R1 has came to this spot. So in this way the pieces keep on moving, and the R pieces has to move to the top of the board, and the B pieces which are computer should come at down here on the board. So the play goes on until any of the player wins the game. So I have uh, sample end state board here. So see here, there are no moves available for the opponent. R3, R2 and R6 are stuck here. They cannot move forward, so the game has ended here. Then we count the pieces. So our pieces, that means the opponent's pieces are 3 and the computer's pieces are 4. So that's why the computer won the game. And if the pieces are of same number, then we count the position of the board, as in which player's pieces have moved to the opposite side. Like for example, if there are more pieces on this side of the computer, like if we have here five pieces of computer and three pieces of here, so that's a difference in the number of pieces. But if we have three pieces of computer available and they all have moved to this place, and the opponent's piece are somewhere in middle the board, in that case the computer will win the game, and vice versa. If there are same number of pieces and the opponent has moved to the other side and the computer is somewhere in the middle, in that case the more points goes to the opponent and opponent wins. And if both computer and the opponent have the same number of pieces and also the same board points, in that case there will be a tie. So this is quite a functionality of our application. So in the code overview, there are some major classes which we have created. For one is for creating the board, which initiates our initial state of the board. The next is the next class is which defines the actions which we can take on the board. So it has like valid moves and then move the piece if the move is valid. The third class is which generates the tree. So it calls this valid moves and move methods in an iterative function. So it generate a tree. So we right now we have kept the depth of the tree as only 2. So only till that state we are generating the child nodes. So this is for the tree generation. The next class is for the calculation of the evaluation function, which calculates the evaluation function for the Minimax algorithm, on the basis of which we select the moves for the computer. The next class is for the implementation of the Minimax algorithm. It implements a recursive Minimax algorithm based on the evaluation function. So the tree which we have generated on using the first third classes, um, that tree is being iterated by this Minimax algorithm. It iterates that tree, it goes to the end of the tree, and then works in a recursive way to get the mini and minimum and the maximum values of the nodes and calculate the best move for the computer. The last class is to implement the rules to end the game and decide the winner. This class takes the state of the game and then checks like if the game is ended, then it decides the winner and ends the game. So this is pretty much the functionality of the code. So the algorithm which we have used here is the Minimax algorithm. It is used to find the move of the computer. So it is very important algorithm for two-player games. Basically, we have two players. One we call as max and other as the min. And the max in our case is the computer, and the min is the opponent. So, and this Minimax algorithm uses the evaluation function to find the best current move, assuming that the next move which the opponent is going to play will be will he will play at his best. And we have applied the recursive Minimax algorithm, and it performs a complete depth first exploration of the game tree. So here is just an example of the Minimax algorithm. There are few sample values we have populated for the Minimax algorithm. Here is the tree which gets generated. It is just a sample tree and not the actual values of our game. They are just the sample values. So in this way, the tree gets generated for each of the legal state, each of the legal move. Different states will get generated. So for the max, we have two different states, and then for the min, in this way, the tree goes on, and these are the terminal states. So once we reach the terminal state, so when the Minimax algorithm works, it explores the tree towards the end, And once we have reached the terminal node means the node which has no children, which has not been explored. So this is the terminal node which we have. So this is the terminal node which we have. So we check the evaluation functions. So we will assign the evaluation functions to the terminal nodes, and then the minimax algorithm, when it reaches this terminal node, it calculates the value for the parent nodes based on the player which is calling this function. For example, the here the min is calling the terminal nodes, so here it will choose the minimum of those values. Then here the max will choose the maximum of these values. So this goes on in a recursive way, and finally the max chooses the maximum of the minimum values which were chosen by the min. Like here minimum has chosen minimum like -8, and here it has taken -10. So max chooses -8. So it tries to go along the path, knowing assuming that the opponent is going to play its best. So in this way the minimax algorithm selects its next move. And so we have used an evaluation function for getting the values of the nodes. This function we have calculated using the number of pieces of both the players, board position of both players, and the captures made by each player. So the first function is like we get the number of pieces of the computer, we get the number of pieces of the opponent, and then subtract one from the other. The next function is basically the board position. So board position is basically for the opposite side. So the number of players on the opposite side, we multiply it by 10, and then for each computer piece we add it, and for each opponent piece we subtract this value. The third one is the capture score. So if um, the the evaluation function is being called from a capture move, like it was a capture, in that case if the capture was done by the computer, we add 50 to the capture score, and if it's from the opponent, we subtract from the opponent. We do this because always the computer will try to maximize the score, and the opponent will always try to minimize the score. So and adding them all together, we get our evaluation function, and this like a plus b plus c, all of them adding together, we get our evaluation function. So this is pretty much it. It's a simple program using the a Minimax algorithm. So right now we have kept a small board, so there can be many future enhancements, like we can increase the size of the board, we can have more pieces, we can have more spots, and when we increase the size of the checkerboard, we can also apply the alpha beta pruning, which is more enhancement of the Minimax algorithm, which cuts off the tree for the values which may never be selected for the exploration. So it also can be done for the larger boards. So these are some future enhancements for our project. And so this is pretty much it for our project. It's just a simple application of checkers using Minimax algorithm, and this is how we play it. uh, Thank you so much. Thank you everyone.